Hello there, and welcome to Science for Sleep, where wonder wraps itself in warm blankets and science gently whispers its secrets as you drift toward rest. Tonight, we'll take a quiet journey into something so familiar, so ordinary, that we often forget just how ancient and extraordinary it really is. A companion to every sip you take, every rain that falls, every breath of mist in the morning air. Tonight, dear traveller, we explore the long, winding story of water, from frozen ice ages to the clear bottle beside your bed. Consider this for a moment. The water you drink today may have once fallen as gentle snow on a woolly mammoth, flowed through ancient rivers that no longer exist, or sat deep beneath the earth for thousands of years before finding its way to your glass. It is in many ways older than memory, older than cities, older than us. And I wonder, as you listen from your corner of the world, where are you tonight? And when you glance at your clock, what time is it there? A simple question, floating on top of a far more ancient current. If you find comfort in these quiet explorations, if this gentle tide of knowledge helps you settle after a long day, I'd be ever so grateful if you tapped like, or perhaps subscribed. It helps this little pool of calm reach others who might need it too. So, settle in, let the world slow, and let's begin. Because somewhere between glaciers and gardens, between cloudbursts and kitchen taps, lies the story of water. Have you ever noticed how water feels? Different depending on the moment. A cool sip after a long walk tastes almost divine. The rhythm of rain against your window on a sleepy afternoon can lull you into the softest kind of calm. The crash of ocean waves can stir something vast and ancient inside you, both peaceful and powerful. And yet it's the same substance. 2 parts hydrogen, 1 part oxygen, over and over. But somehow water doesn't feel the same every time. Its presence shifts with our moods, our needs, our surroundings. It refreshes, it soothes, it terrifies, it nourishes. We don't just drink it, we listen to it, we bathe in it, we play in it, we fear it, we need it. Water in many ways mirrors the human mind. Fluid, adaptable, constantly in motion, and sometimes deceptively still. Think for a moment about the sound of gentle rain. It's strangely comforting, isn't it? That soft pattering seems to hush the world around us, like nature itself is whispering, "It's okay, you can rest now." Psychologists have actually studied this. There's a reason we gravitate toward the sound of rain, rivers, and waves when we want to relax. It's called pink noise, a type of sound that balances frequencies in a way our brains find soothing. Unlike the harsh buzz of city traffic or the sharp clang of alarms, pink noise wraps around us like a soft blanket. The human brain, so attuned to patterns, finds comfort in its gentle randomness. But there's more. Water also holds a strange place in our perception of time. A bubbling brook or rippling pond seems timeless. The waves crashing onto a shore have done so for eons, long before we were here and long after we're gone. Staring into the ocean can feel like staring into forever, a kind of infinite now, and yet water also marks the passing of time. We measure rainfall by the season. We watch puddles evaporate as the sun climbs higher. We trace the rings left by ancient floods. We witness rivers carve valleys over thousands, even millions of years. Water carries the fingerprints of time itself. For many people, a warm bath feels like a little pocket outside of time. Minutes seem to drift, uncounted. The world fades away, and you're simply floating, present yet adrift. Have you ever stood beneath a waterfall, or dipped your feet into a mountain stream? Even a few seconds can feel deeply grounding, almost as though you've plugged yourself back into something ancient. As though, for a moment, the rush of water is washing away not just dirt, but thought, tension, and the weight of time itself. There's a reason so many meditative practices incorporate water, the sound of a fountain, the visualization of flowing rivers, the rhythm of breath likened to waves. Our relationship with water is not just practical, it's deeply psychological. We are drawn to it, comforted by it, even hypnotized by it. There's an old term for this, blue mind, coined by marine biologist Wallace J. Nichols. It describes the mildly meditative state we enter when we're near, in, on, or even simply thinking about water. Our heart rate slows, stress hormones lower, attention narrows, ancestral instincts perhaps, reminding us that water meant life and safety. You see, for most of human history, water wasn't simply a resource, it was survival. The location of water dictated where our ancestors built their homes, planted crops, raised animals, and raised families. A nearby river or spring was not just convenience, it was fate. And that may explain why we still feel something stir inside us when we hear the lap of waves or the whisper of rain on leaves. Buried deep within us is the memory, not personal, but genetic, of depending entirely on this liquid thread that wove through every chapter of our history. But it's not always calming, is it? Water can terrify us too. The vastness of the open sea, the power of a flood, the cold, inky depths of a lake at night. Have you ever felt your heart race when swimming in dark, open water? That primal, unspoken fear of the unknown below? It's not irrational. Our ancestors faced real dangers in those depths. Predators, currents, the risk of drowning. Even today, despite our technology, water demands respect. And yet, isn't it curious that very fear is mixed with awe? We're drawn toward oceans and lakes not only for their beauty, but for their power, like standing at the edge of something enormous that reminds us how small, how fragile, how temporary we are. In this way, water mirrors not just our thoughts, but our very existence, capable of stillness or chaos, life-giver and life-taker, gentle lullaby and roaring force. No wonder then that when we dream of peace we imagine cottages by lakes, hammocks beside rivers, or soft rain against glass. And when we imagine disaster, we envision tidal waves, storm surges, or the chilling silence of the deep. Water plays with our minds, not through any intention of its own, of course, but because we've always projected so much onto it. It's more than just a molecule. For us, it's meaning. Even in language, water floods our metaphors. We speak of emotions welling up. We feel drowned in work. We seek to go with the flow. We pour out our hearts. We fear getting in over our heads. We speak of clear streams of thought or murky decisions. Water offers us endless ways to describe our inner world, as though its behaviour mirrors our own. And perhaps, in some ways, it does. After all, about 60% of your body is water, your brain, closer to 75%, even your very thoughts, your memories, your dreams, are carried along in rivers of neurons bathed in electrolytic fluid. The boundary between you and water is, biologically speaking, not as clear as we might like to imagine. Every cell depends on it. Every breath carries moisture. Every heartbeat is in some way a quiet wave pushing forward. We're walking oceans, and just like the oceans, we ebb and flow. Energy rises and falls, moods shift like tides. Sleep itself arrives like a slow incoming wave, rising gently, carrying us into the dark, quiet waters of dreams. It's no wonder then that so many sleep meditations begin with ocean waves, rainstorms, or flowing streams. Water seems to speak directly to something ancient inside us, bypassing thought, calming the restless currents of the mind. Even our earliest lullabies mimic its rhythm, gentle, rocking, rhythmic, like floating on a mother's breath. There is comfort in water because there is familiarity, an echo of where life began, not just for you, but for all living things. 4 billion years ago, in Earth's primordial oceans, life sparked in microscopic forms, delicate bubbles of molecules drifting in the currents, the first cells, the first breath, the first stirrings of the long, improbable chain that would eventually lead to you, lying here now, listening quietly, breathing softly. And yet, despite all this vast history, water is still immediate, personal. You reach for it when you're thirsty. You bathe in it at the end of a long day. You hear its distant whisper as you fall asleep. It is everywhere, and yet always moving, never quite the same drop twice. Heraclitus, the ancient Greek philosopher, once said, "No man ever steps in the same river twice, for it's not the same river, and he's not the same man." Water reminds us of change, of impermanence, of life's quiet, steady movement forward, and yet it offers stillness too. The smooth surface of a lake at dawn, the steady drip of rain, the hush of snow falling silently on a winter night. In these moments, water seems to hold time still, cradling us briefly in the present, gently whispering, "Be here now." And so, before we dive deeper into water's long ancient history, through glaciers and aquifers, through rivers and pipes, I invite you to pause. Take a slow breath. Feel the rhythm of your own inner tide, the steady, quiet pulse of life. Because the story of water is not just out there, in rivers and oceans, it is within you. And as we follow its journey, we are in a way following our own. Long before we understood molecules, before we named atoms or studied the curvature of space-time, water was already central to the human imagination. It has always been there, falling from the sky, pooling in rivers, slipping between fingers, silent and patient, older than every civilization, yet deeply present in every story we've ever told. For our ancestors, water was not just a substance, it was a mystery, a spirit, a god. Across cultures, across continents, the earliest people looked at rivers, oceans and rain not as chemical compositions, but as living beings. The ancient Greeks spoke of Poseidon, ruler of the seas, whose moods could summon storms or grant calm passages. The Romans called him Neptune, carrying his trident across vast blue plains. In these early tales, water was power, untamed and divine. But they were not alone in this reverence. For the people of ancient Mesopotamia, between the Tigris and Euphrates, water was life itself. Their gods, like Enki, ruled over fresh water, fertility and wisdom. The first great cities rose along these rivers, Babylon, Uruk, Eridu, their prosperity entirely dependent on the river's gentle floods or their terrible rage. To the Egyptians, water was both gift and threat. The Nile, swelling with predictable regularity, brought silt and fertility to the desert. It allowed for agriculture, trade, civilization itself. The Nile's annual flooding was seen as divine generosity. The tears of Isis, some said, mourning her lost Osiris. Without water there would have been no pyramids, no temples, no Egypt. And far to the east, in India, rivers were, and still are, sacred. The Ganges is not merely a river, but Ganga, goddess incarnate, flowing from the heavens to cleanse the sins of mortals. Even today, pilgrims journey to her banks, offering prayers, bathing in her waters, sending the ashes of loved ones downstream to join the eternal current. In Japan, too, water spirits abound, the kami of streams and springs, waterfalls and oceans. Shrines sit beside clear ponds, rituals honour the purifying power of water. The Japanese tea ceremony, slow and meditative, honours water's role in life's simple, sacred rhythms. For the Aboriginal peoples of Australia, waterholes are the veins of the land, connected through dreamtime stories that map creation itself. The great serpents, like rainbow serpents, slithered across ancient lands, carving rivers and valleys as they moved. And across the vast Pacific, Polynesian voyagers navigated thousands of miles using only the stars, the swells, and the whispers of waves against their canoes. For them, water was both pathway and home, a living map spread wide beneath an endless sky. Even in Norse mythology, where ice and fire collide, water held meaning. The primordial void, Ginnunga Gap, separated realms of fire and ice, and from the melting frost arose life itself, dripping into existence. It seems no matter where we look, ancient peoples imbued water with story. They painted their hopes, their fears, their awe onto its ever-shifting surface. But of course, water was not just mythology. It shaped how societies lived, where they settled, how they survived. The first great human migrations followed water. Nomadic tribes wandered toward rivers, lakes, coasts. Settlements grew wherever clean water was found. The great Indus Valley civilization, with its advanced plumbing and meticulously planned cities, flourished beside riverbanks over 4,000 years ago. Aqueducts carried water to Roman baths, fountains, and villas, feats of engineering still admired today. In ancient China, vast irrigation networks allowed rice and wheat to thrive, feeding empires for generations. The Grand Canal, stretching over 1,000 miles, became the world's largest artificial river, connecting distant provinces and unifying an empire. The Inca carved terraces into Andean mountainsides, channeling meltwater through stone channels, an elegant harmony with the land's contours. Water wasn't simply consumed, it was harnessed, revered, protected, and in its absence, or abundance, entire civilizations rose or fell. The Maya of Central America mastered intricate systems of reservoirs and canals, carefully storing rainwater through dry seasons, yet prolonged droughts may have contributed to their decline. Similarly, the legendary city of Petra, hidden among Jordan's cliffs, flourished thanks to complex water catchment and storage, allowing life to bloom in the desert's embrace. And still today we see echoes of these ancient struggles. Cities grow where water flows, conflicts arise where rivers cross borders, droughts strain economies, floods test resilience. But alongside these practical concerns, cultural reverence for water remains deeply woven into rituals, idioms, and everyday expressions. Consider how often water slips into language. We test the waters before making decisions. We speak of stormy relationships or emotions that bubble up. We tread water during difficult times. We break the ice to ease conversation. We describe ideas as fluid or crystal clear. Tears are called streams of sorrow. It's as if, across languages, water becomes the perfect metaphor for change, uncertainty, and emotion. Always moving, always adapting, sometimes calm, sometimes wild. Even in spirituality, water remains a powerful symbol of renewal. In Christianity, baptism symbolizes rebirth, emerging from water as from the womb, washed clean. In Islam, ritual washing, wudu, purifies body and mind before prayer. In Buddhism, water offerings symbolize clarity and humility. Throughout history, water has not only been sacred, it has been seen as the very boundary between worlds. The ancient Greeks placed the dead on boats, their souls ferried across the river Styx by Charon. The Vikings sent their honoured dead onto fiery ships sailing toward Valhalla. Water, it seems, was not just for the living, but a passage for the departed. Even our dreams often bring us to water. Psychologists note that water in dreams reflects our inner emotional states. Calm lakes suggest peace. Stormy seas hint at turmoil. Floods may symbolize being overwhelmed. In this way, water continues to mirror us, just as it always has. And yet, for all its spiritual and poetic meaning, water's relationship with humanity has not always been gentle. Great floods fill the myths of many cultures. The Epic of Gilgamesh, one of the oldest written stories, speaks of gods unleashing a flood to cleanse the earth. The Hebrew Bible tells of Noah's Ark, a vessel of salvation amidst divine deluge. Hindu texts describe a Manu warned of a great flood by the fish avatar Matsya. In Chinese legend, hero Yu the Great tames the floods of the Yellow River, bringing peace to the land. Flood myths, found on every continent, reflect not only the fear of nature's power, but perhaps ancient memories of real deluges that reshaped landscapes and lives. Even today, modern science suggests that rising sea levels at the end of the last ice age may have inspired some of these tales, vast floods swallowing coastlines as glaciers melted, because water, as much as we revere it, has always held the power to destroy as easily as it gives life. Tsunamis, hurricanes, rising seas, these remain among nature's most devastating forces. And yet, we return to its shores. We build cities along its banks. We swim in its depths. We listen to its whispers. Why? Perhaps because, deep down, we recognize something familiar. We sense that water's story is intertwined with our own. We began, after all, in water. Every one of us floated in amniotic fluid before drawing first breath. The oceans were the cradle of all life. Even now, every heartbeat sends waves through rivers of blood, every cell bathed in liquid. We are not merely near water, we are water. And so we remain drawn to it, comforted by it, humbled by it. In art, in poetry, in song, water flows endlessly. The Japanese haiku master Basho wrote, "An old silent pond, a frog jumps into the pond, splash, silence again." In just a few syllables, the gentle dance of stillness and motion, of water's delicate balance, is captured. In ancient Chinese philosophy, Laozi taught through the Tao Te Ching, nothing in the world is as soft and yielding as water, yet for dissolving the hard and inflexible, nothing can surpass it. And even in modern times, water continues to inspire. We watch fountains rise and fall. We listen to rain machines in meditation apps. We sit beside lakes, quietly watching ripples fan outward. The cultural thread remains unbroken. As we prepare to follow water's journey into science, into glaciers, rivers, and the bottles we drink from, we carry with us these ancient echoes. For long before we measured water by litres or studied its molecular bonds, we sang to it, prayed to it, feared it, honoured it. Water, it seems, has always held more than just life. It holds memory, myth, meaning. And even as science unfolds its secrets, the quiet poetry of water still flows, inviting us to listen. So far we've wandered through water's poetic reflections, ancient myths and cultural echoes, but now, gently we'll shift our gaze toward the quiet, elegant science beneath the surface, because while water has been a god, a symbol and a mystery, it is also a molecule, a simple one at first glance, 2 hydrogen atoms, 1 oxygen atom, H2O, just 3 tiny particles bound together by invisible forces. And yet, this humble triangle of atoms holds properties so unusual, so perfect for life, that even today scientists marvel at its quirks. Let's start at the very beginning, where water itself began. You see, most of the hydrogen in water was born during the Big Bang, nearly 13.8 billion years ago. Moments after the universe's fiery birth, as temperatures cooled, hydrogen atoms formed from the first protons and electrons. Oxygen, on the other hand, came much later, inside the hearts of stars. When massive stars lived and died, they forged heavier elements, including oxygen, in their fiery cores. These stars exploded in spectacular supernovae, scattering oxygen atoms into the vast cold stretches of space. It was there, amidst clouds of gas and dust, that hydrogen and oxygen finally met, forming water molecules that drifted through newborn galaxies. Some of these water molecules froze into tiny icy grains, eventually trapped within comets, asteroids, and planetary embryos. And when Earth itself took shape, roughly 4.5 billion years ago, water arrived from many sources. Some was trapped inside the planet's rocky mantle. Some may have rained down from icy comets bombarding the young world, and some may have condensed from volcanic gases rising from Earth's hot interior. Whichever path it took, water soon filled Earth's basins, forming oceans as the planet cooled. And those oceans have been here ever since. Rising, falling, evaporating, freezing, flowing. The same water, the very same molecules, circulating endlessly through a cycle known as the hydrologic cycle, Earth's great water engine. Let's drift gently through that cycle now. It begins with the warmth of the sun. Sunlight strikes oceans, lakes, rivers, lifting water molecules into the air as water vapor. This process, evaporation, sends countless invisible droplets upward. High in the sky, cooler temperatures cause vapor to condense into tiny droplets forming clouds. Eventually, when enough droplets gather, gravity pulls them back down as rain, snow, sleet or hail, precipitation. Some of this water falls into rivers, flowing downhill, carving valleys, feeding lakes and eventually returning to the oceans. Some seeps into the ground, becoming groundwater, hidden beneath our feet in vast underground reservoirs called aquifers. Some of it, pulled up by the roots of plants, rises through stems and leaves, released again as vapor in a process called transpiration, a kind of quiet, leafy exhalation. And so, round and round the cycle turns, endlessly moving, endlessly transforming. Every raindrop you feel on your skin once travelled this ancient pathway. The water in your glass tonight may have fallen as rain onto a dinosaur's back. It may have been locked in a glacier for millennia, or flowed through the roots of ancient forests. In this way, water is both ancient and immediate, a perfect recycler. But water's true magic lies not only in its cycle, but in its bizarre and life-giving properties. You see, water does not always behave like other liquids. In fact, it often breaks the rules. Let's start with one of its most famous oddities. Its solid form floats on its liquid form. This is surprisingly rare in the world of chemistry. Most substances become denser when they freeze. Their molecules pack closer together. But water, when it freezes into ice, it expands. Its molecules arrange into a crystal lattice that takes up more space than when they're freely moving in liquid form. The result? Ice floats. And because ice floats, lakes and oceans freeze from the top down, forming insulating layers that protect life beneath, even in the coldest winters. Were it not for this quirk, entire ecosystems could freeze solid, extinguishing life each winter. This single property, floating ice, helps explain how life was able to survive repeated ice ages over Earth's long history. Then there's water's remarkable heat capacity. Its ability to absorb large amounts of heat without dramatically changing temperature. This is why coastal regions experience milder climates than inland areas. The oceans act like giant thermal buffers, absorbing heat in the summer and releasing it slowly in the winter. It's also why your cup of tea stays warm for a while, and why it takes time to boil water in the first place. This heat buffering ability has helped stabilize Earth's climate for billions of years, allowing life to thrive. But water's magic doesn't stop there. It's often called the universal solvent, able to dissolve a vast range of substances, salt, sugar, minerals, gases, all readily mix into water. This ability allows nutrients to circulate inside your body, carried through blood plasma. It allows rivers to transport minerals to the oceans. It enables plants to pull nutrients from soil. It allows life's chemistry to happen. Inside every living cell, countless chemical reactions occur in watery solutions. DNA floats in water. Proteins fold and unfold in water. Energy flows through water. Without water's dissolving powers, biology as we know it would simply not function. Even its surface is special. Water molecules cling to one another through tiny electrical attractions called hydrogen bonds. These bonds give water an unusually high surface tension, allowing insects to walk across ponds, droplets to bead on leaves, and your favourite warm cup of tea to hold its dome-shaped meniscus. Hydrogen bonds also help explain water's high boiling point, its ability to form capillary action in plants, and its slow evaporation rate. In short, water is weird. Beautifully, perfectly weird. A molecule designed, whether by chance, physics, or cosmic fortune, to support life. And yet, for all its familiar presence, water can surprise us with its extremes. Consider the vast glaciers, frozen rivers of ice, slowly grinding their way down mountain valleys. Glaciers carve landscapes into sharp peaks and deep fjords. They hold even today massive reservoirs of fresh water locked in ancient ice. Or think of the deep ocean trenches, where water plunges miles beneath the surface into cold, crushing blackness. Down there, in the Hadal zone, bizarre creatures thrive under pressures that would crush submarines, all still depending on water's strange chemistry. At both extremes, frozen mountaintops and abyssal depths, water continues to cradle life in forms we're still discovering. Even in places that seem bone dry, water hides. Deep beneath deserts lie underground aquifers, ancient, slow-moving reserves that may have been trapped for thousands of years. In caves, water drips steadily, drop by drop, building intricate stalactites and stalagmites over centuries. And in Earth's atmosphere, water vapor floats invisibly, creating clouds, storms, and spectacular rainbows. Water is everywhere, sometimes visible, sometimes hidden, always moving. But as we zoom in even closer, down to the atomic level, we see just how strange water truly is. Each water molecule is shaped like a tiny bent boomerang. The two hydrogen atoms sit at a slight angle to the oxygen, creating a dipole. One end slightly positive, one slightly negative. This polarity is the secret behind so many of water's unusual traits. The molecules tug on one another through tiny attractions, constantly forming and breaking bonds in a kind of microscopic dance. In a single glass of water, trillions of these bonds form and dissolve every second, creating the liquid's flowing, slippery nature. Water is not a passive backdrop for life. It's an active participant, a dynamic, responsive partner in every biological process. And yet, for all its complexities, water remains humble. It asks for nothing. It flows where it's guided. It shapes mountains over millennia, yet yields to the gentlest touch of a fingertip. It is in many ways a perfect paradox. Soft yet strong, simple yet complex, common yet extraordinary. As we continue, we'll explore how water shapes not just biology, but geology, climate, and even the bottles sitting quietly on our tables. Because water's journey, from ancient ice ages to modern industry, is still unfolding. As we continue following water's story, we begin to see how it shapes not just life itself, but the very face of our planet. Every mountain carved, every valley formed, every coastline drawn and redrawn over eons. Water is the great sculptor, endlessly patient, endlessly persistent. Consider the ice ages, those long, frigid chapters in Earth's history when glaciers advanced across continents. Roughly 2.4 million years ago, the Pleistocene epoch began, a period defined by the advance and retreat of massive ice sheets. Vast glaciers up to 3 kilometers thick blanketed much of North America, Europe, and Asia. As the ice moved, it scraped bedrock, carved fjords, and left behind great scars upon the land. When the glaciers melted, they created lakes, like the Great Lakes of North America, and deposited enormous hills of rock and sediment known as moraines. Even now, if you've ever stood at the edge of a fjord or admired a smooth U-shaped valley, you're gazing upon the quiet handiwork of ancient ice and water. But water's sculpting is not limited to grand icy canvases. Even a tiny stream, given enough time, can slice through solid rock. The mighty Grand Canyon, for example, was carved by the steady flow of the Colorado River over millions of years, drop by drop, grain by grain, layer by layer. Water doesn't rush, it waits. In warmer regions, water shapes the land in different ways. In karst landscapes, rainwater, slightly acidic from dissolved carbon dioxide, seeps into limestone, slowly dissolving the rock to form vast cave systems, sinkholes, and underground rivers. The stunning caverns of Carlsbad, the sprawling networks beneath Kentucky, the crystal chambers in Mexico, all carved by water's quiet, persistent touch. Even underground, water sculpts with grace. Water also governs the sky. The clouds drifting above you are simply collections of tiny water droplets or ice crystals suspended by air currents. Clouds come in countless forms: fluffy cumulus, towering cumulonimbus, wispy cirrus, soft stratus, each shaped by temperature, humidity, and wind. When conditions shift, water falls back to earth as precipitation, nurturing fields, filling rivers, and sustaining forests. Without this cycling, life would falter, but water's influence reaches even beyond the atmosphere. High above, water vapor plays a crucial role in regulating Earth's climate. Although we often focus on carbon dioxide and methane, water vapor is the most abundant greenhouse gas, trapping heat and maintaining Earth's warmth. Without water vapor, our planet would plunge into frigid darkness. But like everything with water, balance is key. Too much warming, too much evaporation, and the climate shifts unpredictably. Even today, as humans add more greenhouse gases to the atmosphere, water responds. Rising temperatures increase evaporation. Warmer air holds more moisture, and so the water cycle intensifies, bringing stronger storms, heavier rains, prolonged droughts. The climate and water are locked in a delicate dance, one affecting the other in countless invisible ways. And yet, for all its planetary importance, water is also deeply personal. Let's zoom back down into your body. Roughly 60% of you is water, but it's not evenly distributed. Your brain, roughly 75% water. Your lungs, about 83%. Your muscles and kidneys, close to 79%. Even your bones, solid as they seem, hold about 31% water. Every heartbeat sends blood, mostly water, carrying oxygen and nutrients to your cells. Every breath passes moist air in and out. Every thought you have depends on water cushioning your brain, protecting neurons, facilitating electrical signals. Without water, even for a short time, your body struggles. Within just a few hours of dehydration, fatigue sets in. Concentration fades, headaches arrive, your organs begin to strain. Water is not just a fuel, it is your medium, the liquid canvas upon which every heartbeat, thought, and breath is painted. But of course, not all water is safe to drink. Around the world, water quality remains a critical concern. Natural sources may contain harmful microbes, parasites, heavy metals, or chemical pollutants. Even crystal-clear mountain streams, seemingly pristine, can harbour invisible pathogens like Giardia or Cryptosporidium. This is why, for centuries, humans developed ways to purify water: boiling, to kill bacteria and parasites; sand filtration, to remove particles; charcoal filtering, to absorb impurities; distillation, separating pure water from contaminants through evaporation; modern chemical treatments such as chlorine and ozone disinfection. Today, entire industries revolve around purifying water, ensuring that what flows from your tap or fills your bottle is safe, clean, and refreshing. Which brings us to one of modern water's most curious chapters: the rise of bottled water. In many parts of the world, tap water is perfectly safe, heavily regulated and rigorously tested, and yet bottled water sales have soared, becoming a global multi-billion-dollar industry. Why? Partly convenience, partly marketing, partly perception. Crisp mountain imagery, promises of purity, and sleek packaging all suggest bottled water is somehow better, even when it often originates from municipal supplies. In some places, bottled water is essential, where infrastructure is lacking or contamination is widespread. But in much of the developed world, bottled water represents a strange paradox. An abundant resource, repackaged and sold back to us at a price far beyond its actual cost. And yet, the bottles accumulate. Each year, millions of tons of plastic enter our oceans, where waves and sunlight break them down into tiny particles, microplastics. These fragments drift through the seas, entering food chains, and, increasingly, returning to us. Even in bottled water itself, microplastics have been detected. A reminder, perhaps, that water's cycle is not only ancient, but increasingly entangled with modern challenges. But beyond the chemistry, beyond the economics, beyond the industry, water still retains its quiet wonder. Consider the simple beauty of snowflakes. Each one forms as a tiny dust particle, high in the atmosphere gathers water vapor, which freezes into intricate crystals. The angle of water molecules naturally form hexagonal symmetry, creating snowflakes with 6 delicate arms, no two exactly alike. Billions fall with every storm, each a tiny sculpture. Or think of dew, those glistening beads that appear on grass at dawn. As night cools the air, water vapor condenses onto surfaces, forming perfect droplets that catch the morning light like scattered jewels. Or the strange stillness after a heavy snowfall when sound is muffled and the world seems hushed beneath a soft white blanket. In all these moments, water quietly reminds us of its grace. Even rainbows, those fleeting arches of colour, are simply sunlight refracting through raindrops. As light enters a droplet, it bends, reflects inside, and emerges spread into its spectrum. Reds, oranges, yellows, greens, blues, indigos, violets. A sky painted by millions of tiny lenses, each drop bending light just so. In every rainbow, water plays the artist, painting with sunlight. And then there is fog, water suspended in air, blurring edges, softening the world. Walking through fog feels like moving through a dream. Shapes fade, sounds grow distant, and time itself seems to slow. Water can turn even the air itself into a soft floating veil. In every form, vapor, liquid, ice, water moves between states with a kind of quiet grace. It evaporates, condenses, freezes, melts, cycling endlessly, seamlessly. Phase changes, as scientists call them, governed by temperature and pressure. Yet to us, they feel like tiny miracles. Steam swirling from a tea kettle, frost etching windows on a cold morning, icicles growing, drop by patient drop, clouds drifting like floating mountains. Water's transformations are constant yet always gentle. And so, as we near the end of this scientific layer, we might pause and marvel at just how elegantly peculiar water is, born from ancient stars, sculptor of continents, cradle of life, mirror of mood, both ancient and immediate, both fragile and eternal. It fills our world, our bodies, our dreams. A simple molecule, H2O, carrying within it the story of our planet, and perhaps the story of us. In the next part of our journey, we'll trace how humanity's understanding of water has evolved, from ancient myths to modern science, and the remarkable minds who've helped us glimpse its mysteries, because while water itself has remained unchanged, our ways of seeing it have grown deeper, like peering into a lake whose surface hides endless depths. Water's story becomes even more fascinating when we begin to explore its deeper mechanisms and the strange behaviours that emerge under certain conditions. Though deceptively simple in composition, water reveals complexities that continue to puzzle scientists even today. Consider first how water behaves under extreme pressure. Deep within Earth's mantle, water exists in forms that are unfamiliar to everyday experience. High pressure forces water molecules into dense arrangements, forming exotic phases of ice unlike the kind that floats in your glass. Scientists have discovered more than 20 different types of ice, labelled with names such as Ice 2, Ice V, Ice 7, and beyond. Each variety possesses unique molecular structures, rearranged by immense forces that do not occur at Earth's surface. Ice S7, for example, forms under pressures exceeding 30,000 times atmospheric pressure. It exists deep within planetary interiors and may even reside beneath the surface of distant moons like Europa and Ganymede. Researchers believe that these hidden oceans beneath icy shells could harbour life, sustained by warmth from the moon's core and protected from harsh space radiation. The possibility of life thriving beneath miles of frozen surface continues to fuel some of the most intriguing research in astrobiology. Shifting from the distant cosmos to the laboratory, water's behaviour continues to surprise. Supercooled water can remain liquid well below its normal freezing point, provided that it remains undisturbed and pure. Tiny impurities or disturbances trigger sudden freezing, releasing stored energy and rapidly forming ice. This unusual state has practical applications in medicine, especially in cryopreservation techniques where biological tissues are preserved at extremely low temperatures without forming destructive ice crystals. Water also plays an essential role in regulating Earth's climate far beyond its presence in oceans and clouds. In polar regions, vast sheets of sea ice reflect sunlight, helping to moderate global temperatures. This reflective quality, known as albedo, determines how much solar energy is absorbed versus reflected back into space. Melting ice reduces albedo, causing more energy to be absorbed, which in turn accelerates warming. This feedback loop contributes significantly to current concerns about climate change and the delicate balance maintained by our planet's water systems. Moving closer to the surface, water's ability to transport energy and nutrients defines entire ecosystems. Ocean currents such as the Gulf Stream transfer warm water from the tropics toward the poles, while colder, denser water sinks and returns along the ocean floor. These massive conveyor belts not only distribute heat, but also carry dissolved oxygen and nutrients that sustain countless forms of marine life. A disruption in these currents would have profound effects on weather patterns, food chains, and even global economies. Water's role extends beneath the soil as well. Groundwater silently flows through porous rock layers, forming vast underground reservoirs that supply drinking water to billions. Aquifers like the Ogallala in North America have supported agriculture for generations. However, these resources are not infinite. Over-extraction lowers water tables, making wells run dry and causing land subsidence as the empty pores collapse. The slow pace of aquifer recharge means that unsustainable use can permanently deplete these hidden reserves. In urban environments, water presents both blessings and challenges. Modern cities rely on intricate networks of pipes, pumps, and reservoirs to deliver clean water to millions. At the same time, wastewater systems return used water for treatment, purification, and often reuse. Sophisticated filtration technologies remove contaminants, while biological processes break down organic waste. Many cities now practice water reclamation, turning wastewater into potable water through advanced treatment. This closed-loop approach reduces strain on freshwater sources and represents one of the most promising solutions to future water scarcity. Turning attention to agriculture, water reveals its most visible role in sustaining civilization. Irrigation has transformed arid regions into fertile farmland for thousands of years. Systems such as ancient Mesopotamian canals and the Qanats of Persia guided water across vast distances to feed crops. Today, modern drip irrigation techniques maximize efficiency, delivering water directly to plant roots and reducing evaporation losses. Precision agriculture employs sensors, data analysis, and satellite imagery to monitor moisture levels, ensuring that water is used with remarkable care and accuracy. Yet, agriculture remains one of the largest consumers of freshwater globally. Producing a single kilogram of rice requires thousands of litres of water. Beef production demands even more, as water supports not only the animals but the crops they consume. This intensive demand creates tension between agricultural needs and limited freshwater supplies, especially in regions already facing drought and population growth. water's journey continues beyond farms and cities, extending into the energy sector. Hydroelectric power stations convert the kinetic energy of falling water into electricity, providing renewable, low-emission energy to millions. Dams such as the Hoover Dam and Three Gorges Dam stand as testaments to humanity's ability to harness water's force for industry and daily life. However, dams alter river ecosystems, disrupt fish migrations, and can displace communities. Balancing energy production with ecological responsibility remains a complex challenge. Thermal power plants, whether fueled by coal, natural gas, or nuclear reactions, also depend heavily on water. Steam turbines generate electricity as water transforms from liquid to vapour and back again. Cooling towers, often seen billowing white clouds, return that vapour safely to the atmosphere. Water's extraordinary heat capacity and phase transitions make it indispensable to modern power generation, yet these processes consume significant volumes, further linking water to energy policies and resource management. Beyond industry, water carries cultural and emotional weight even in scientific research. Oceanographers speak of the deep with reverence, while glaciologists trace the flow of ancient ice with quiet awe. Hydrologists map invisible rivers beneath deserts, uncovering lost oases and forgotten pathways. Each discipline, though grounded in data and observation, remains intimately connected to water's quiet mysteries. Emerging technologies now allow scientists to study water at unprecedented scales. Remote sensing satellites map global moisture levels, track glacier movements, and monitor sea level rise with astonishing precision. Isotope analysis reveals the origins of ancient rain trapped in polar ice cores, offering glimpses into Earth's climatic past stretching back hundreds of thousands of years. Even now, ice cores pulled from Greenland and Antarctica reveal bubbles of ancient atmosphere, frozen snapshots that allow researchers to reconstruct temperature shifts and greenhouse gas concentrations long before human records began. Water holds the memory of Earth's past, not only in ice but in rock. Sedimentary layers preserve records of ancient rivers, floods and droughts, encoding clues to the rise and fall of civilizations. Lake sediments accumulate pollen grains, ash layers, and mineral traces, quietly recording environmental changes over millennia. The story of water intersects with geology, biology, chemistry, and physics at every turn. Its behaviour influences tectonic activity, supports deep-sea thermal vents, shapes weather systems, and forms the foundation of nearly every living process. Though scientists categorise and model these processes in countless equations, the underlying substance remains one of nature's most elegant contradictions. On one hand, water follows strict rules of molecular interaction, dictated by charge distributions and bond angles. On the other hand, it slips through definitions, bending those same rules to form complex behaviours that continue to challenge even advanced computer simulations. Water's anomalies have given rise to entire fields of study dedicated solely to understanding why this molecule refuses to behave like others. Many questions remain unanswered. Researchers continue to probe the precise mechanisms behind water's strange freezing behaviour, its supercooled states, its high surface tension, and even its role in protein folding and enzyme function within living cells. Some scientists refer to water as an unresolved problem despite centuries of careful study. These ongoing mysteries serve not as frustrations but as invitations, reminders that even the most familiar substances hold layers of wonder yet to be discovered. Water, so constant and close, remains as full of unanswered questions as distant galaxies and subatomic particles. The deeper one looks into water's nature, the more unexpected connections begin to appear. Even at the smaller scales, water participates in phenomena that ripple far beyond chemistry textbooks. In the world of quantum mechanics, water plays a subtle, yet significant role. The movement of hydrogen atoms within the molecule involves quantum tunneling, a process where particles pass through energy barriers they seemingly should not cross. This allows hydrogen bonds to form and break in ways that influence water's remarkable fluidity and flexibility. These strange behaviours happen constantly, unnoticed by us, but essential to everything from protein folding to the replication of DNA. Moving into the realm of biology, water's influence becomes even more intimate. Life on Earth likely began in water. Early primordial soups, rich with simple organic molecules, offered the perfect setting for chemistry to begin its long transformation into biology. Over countless generations, small self-replicating molecules grew more complex, ultimately giving rise to the first single-celled organisms. Water provided not just a solvent for these early reactions, but also a stabilizing environment where temperature, pH, and nutrient availability fluctuated gently compared to the harsh extremes of land or air. The flexibility of water's hydrogen bonds allowed biological molecules to maintain their shapes and functions, a delicate balance that persists inside every living cell today. Within your own body, every biochemical reaction takes place in water's embrace. Enzymes rely on the fluidity of their surroundings to shift, twist, and catalyze reactions. Ion channels embedded in cell membranes regulate flows of charged particles, controlling nerve impulses, muscle contractions, and heartbeats. Water serves not merely as a backdrop, but as an active participant, guiding the choreography of life's molecular dance. This intimate relationship continues throughout every level of life's hierarchy. Plants draw water through capillary action, aided by cohesive forces between water molecules and adhesive forces to cell walls. Trees towering above city skylines lift water dozens of meters into the air without pumps, relying solely on evaporation and surface tension to pull moisture upward from roots to leaves. Every time wind rustles leaves, tiny pores release moisture into the air, sustaining the endless exchange between earth and sky. In the animal world, water shapes migrations, breeding patterns, and survival strategies. Salmon swim upstream to their spawning grounds, guided by subtle chemical signatures carried in rivers. Desert creatures survive on dew collected from morning air. Amphibians depend on moist habitats to protect their permeable skin. Migratory birds time their flights with rainfall cycles, while whales navigate oceans rich with plankton blooms, fueled by upwelling nutrient waters. Entire ecosystems revolve around the availability, timing, and purity of water. Wetlands act as natural water filters, absorbing pollutants while providing habitat for countless species. Coral reefs thrive in nutrient-balanced seas, where water clarity allows sunlight to reach photosynthetic algae living within coral tissues. Excess nutrients from runoff disrupt these balances, causing harmful algal blooms and bleaching events that threaten biodiversity. Water also shapes the rhythm of seasons. Monsoon rains define planting cycles for billions of people. Snowmelt feeds rivers that irrigate fertile plains. Permafrost locks away carbon and methane beneath frozen ground, releasing them when thawed, potentially altering global atmospheric balances. The stability of these seasonal patterns depends heavily on the delicate interplay between air temperatures, ocean currents, and ice formations, all mediated by water's many forms. In recent decades, scientific tools have provided unprecedented insight into these processes. Satellite missions such as NASA's GRACE, Gravity Recovery and Climate Experiment, have measured changes in Earth's gravity caused by shifting water masses. These data reveal shrinking glaciers, receding ice sheets, and falling groundwater reserves, offering real-time glimpses into humanity's growing impact on the planet's hydrologic systems. The melting of polar ice, in particular, illustrates both the sensitivity and complexity of water's global role. Greenland's ice sheet, holding enough frozen water to raise sea levels by 7 meters, has begun losing mass at accelerating rates. Sea ice in the Arctic shrinks each summer, exposing dark ocean surfaces that absorb heat, amplifying warming through feedback loops. rising seas threaten coastal cities, fragile islands, and estuaries worldwide, placing millions at risk. Ocean acidification adds another layer of complexity. Increased carbon dioxide levels dissolve into seawater, forming carbonic acid that lowers pH levels. Coral skeletons, shellfish, and plankton depend on carbonate ions to form their protective shells. Acidifying oceans reduce the availability of these ions, jeopardizing entire food webs from the microscopic foundation upward. Meanwhile, freshwater resources face their own pressures. Rivers like the Colorado, Nile, and Yangtze serve vast populations but struggle under competing demands for agriculture, energy, and urban expansion. Glaciers that once fed these rivers during dry seasons retreat further each year. Drought-prone regions depend increasingly on engineered solutions, such as massive dams and complex legal agreements over water rights, to balance competing needs. Technology offers both solutions and complications. Desalination plants now transform seawater into drinking water, particularly in arid regions such as the Middle East and California. These plants require significant energy and produce highly concentrated brine waste, which must be carefully managed to avoid harming marine ecosystems. Though desalination offers hope, its cost and environmental impact remain subjects of debate. In parallel, engineers explore innovative water harvesting techniques. Atmospheric water generators pull moisture directly from humid air. Solar stills distill water using sunlight. Even advanced materials inspired by desert beetles and spider silk channel dew and fog into liquid reservoirs. These emerging technologies aim to provide decentralized, sustainable solutions for communities facing water scarcity. Despite technological advances, many challenges remain deeply social. Access to clean, safe drinking water continues to elude millions. Contaminants such as lead, arsenic, industrial chemicals, and microbial pathogens threaten health in both developing and industrialized nations. The struggle to ensure universal access to potable water remains one of the great moral and logistical challenges of the 21st century. Water governance grows increasingly complex. Transboundary rivers cross political borders, creating potential conflicts between nations. The Nile Basin, shared by multiple countries, exemplifies the delicate negotiations required to balance upstream and downstream interests. Similar tensions arise in the Indus, Mekong, and Tigris-Euphrates basins. Diplomacy, law, and science must work hand in hand to ensure equitable and peaceful management of shared water resources. At the personal level, individual choices echo these global issues. Household water use, from showers to washing machines, from lawns to drinking bottles, contributes cumulatively to overall demand. Many communities now adopt water-saving practices such as low-flow fixtures, rainwater harvesting, grey water recycling, and drought-resistant landscaping. These small steps, multiplied across millions, offer real potential to ease pressure on limited supplies. Even the cultural perception of water evolves with growing awareness. Schools, documentaries, and public campaigns increasingly emphasize conservation, highlighting water's finite nature and immense value. Artists create installations inspired by melting glaciers and shrinking lakes. Poets and musicians continue to weave water's imagery into songs and verses, blending scientific urgency with human emotion. Despite its universality, water remains deeply personal. A single drop can symbolize purity, renewal, or fragility. In ceremonies across cultures, water welcomes newborns, purifies sins, and marks rites of passage. From baptismal fonts to holy springs, from tear-streaked cheeks to ocean pilgrimages, water occupies a sacred place in the tapestry of human life. Throughout history, water has invited reverence precisely because it sustains existence while remaining fundamentally uncontrollable. No matter how many pipelines are built or reservoirs constructed, floods still rise and droughts still burn. water yields to human effort only within the bounds set by nature's larger cycles. Its patience far exceeds any human planning horizon. In this interplay of science and mystery lies water's enduring fascination. Researchers calculate its properties with extraordinary precision. Governments regulate its distribution with careful policy. Yet, in quiet moments, standing beside a stream or watching rain bead against glass, one feels its ancient, unspoken presence, always familiar, never fully grasped. Every molecule cycles endlessly, rising as vapor, falling as rain, coursing through rivers, freezing in glaciers, nourishing life, and returning again. This eternal dance continues whether anyone watches or not. Water, it seems, has always been both profoundly ordinary and endlessly extraordinary. No matter how deeply science peers into its structure, its presence evokes something elemental in the human spirit, a quiet reminder of our place within nature's vast flowing rhythm. Throughout much of human history, water was not studied. It was lived with, observed, worshipped, feared, used. People understood its importance through direct experience long before anyone attempted to explain its nature. The first human understanding of water was not chemical, but spiritual. Early humans watched rain fall from the sky and rivers rise with the seasons. They saw crops flourish after rains and die in droughts. Water's power was immediate, its influence obvious, yet its source, its movement, its very being remained mysterious. In ancient Babylonian texts, water appears as one of the primal forces of creation. The Sumerians spoke of the primeval sea from which all life emerged. The Egyptians revered the Nile as a divine artery, pulsing with the breath of the gods. The Greeks, while personifying water in gods like Poseidon, also began taking tentative steps toward explanation. Thales of Miletus, often regarded as the first philosopher-scientist of the Western tradition, lived around 600 BCE. His bold assertion was both simple and profound. Everything is made of water. To Thales, water was not merely a substance but the fundamental principle from which all things arose. Though his theory lacked the atomic precision of modern chemistry, it reflected a deep intuition about water's universality. In India, thinkers of the Vedic tradition placed water among the 5 great elements, along with earth, fire, air, and space, composing the universe. In China, the philosophy of the 5 elements also included water as a primary force, associated with winter, emotion, and the flow of life. Across continents and cultures, early thinkers sensed that water was somehow at the root of existence. For centuries, this elemental view of water persisted. It wasn't something to be broken down or analysed, but accepted as one of nature's basic building blocks. The idea of dissecting water into smaller components had not yet occurred. Then came alchemy. During the Middle Ages and into the Renaissance, alchemists in Europe, the Middle East and Asia began experimenting with substances. Water, alongside mercury, sulfur and salt, played a central role in their mystical laboratories. Though often wrapped in spiritual language, alchemy laid some groundwork for future chemical investigation. Practitioners distilled, purified, and transformed liquids, slowly refining techniques that would one day form the basis of modern chemistry. It wasn't until the 18th century that water's true nature began to reveal itself. The question of whether water could be broken down into simpler parts intrigued scientists as experimental tools improved. Joseph Priestley, Henry Cavendish, and Antoine Lavoisier, 3 names often intertwined in the unravelling of water's mystery, worked independently to probe its composition. Cavendish, working in England during the 1780s, conducted careful experiments mixing what he called inflammable air, now known as hydrogen, with dephlogisticated air, oxygen, and igniting the mixture. The result was not smoke or ash, but droplets of pure water. This experiment revealed that water was not elemental, but could be synthesized from simpler gases. Across the Channel in France, Lavoisier confirmed and expanded these findings. His experiments, methodical and precise, demonstrated that water was a compound, 2 parts hydrogen, 1 part oxygen. Lavoisier's work laid the foundation for modern chemical understanding and dismantled the ancient notion of water as one of the irreducible elements. Through these revelations, water's mystery deepened rather than diminished. No longer a simple essence, it became a molecular structure, a precise arrangement of atoms. Chemistry had peeled away one veil, revealing another layer of complexity beneath. The 19th century saw the rise of physical chemistry and thermodynamics. Scientists such as Lord Kelvin and Rudolf Clausius studied the energy exchanges involved in phase transitions, how water absorbed or released heat while boiling, freezing, or evaporating. These investigations led to deeper insights into entropy, energy conservation, and the laws that govern not just water, but the entire physical world. In 1865, Clausius formally introduced the second law of thermodynamics, which described the inevitable increase of disorder, entropy, in closed systems. The behavior of water during phase changes became one of the clearest demonstrations of these principles. Every boiling pot of water, every melting glacier, and every droplet of condensation carried within it echoes of these invisible laws. During this same era, advances in microscopy and crystallography allowed scientists to peer more closely at ice. They mapped the hexagonal structure of ice crystals, revealing the elegant lattice formed by hydrogen bonds. These bonds explained why ice expanded rather than contracted, why it floated, and why lakes froze from the top down. Insights that earlier generations could scarcely have imagined. By the early 20th century, water became a subject not only for chemists, but for physicists, geologists, and biologists alike. The discovery of quantum mechanics added new layers of mystery. Hydrogen bonding, once explained purely through classical attraction, revealed subtler interactions governed by the strange probabilities of the quantum world. The flexibility and behavior of water molecules at the subatomic level defied easy description. Even now, some aspects of hydrogen bonding remain actively researched. At the same time, glaciologists began unraveling the story of water on a planetary scale. Ice cores drilled from Greenland and Antarctica preserved bubbles of ancient atmosphere trapped in frozen water. These frozen time capsules offered records stretching back hundreds of thousands of years, revealing past climate changes, atmospheric composition, and temperature shifts that informed our understanding of Earth's dynamic climate system. In parallel, oceanographers charted the vast global currents, the thermohaline circulation, that shuttle heat, salt, and nutrients across the oceans. The Gulf Stream, the Antarctic Circumpolar Current, and the slow descent of cold water into oceanic depths formed parts of a massive, interconnected system that regulates Earth's climate. Water, flowing not just on the surface but through deep ocean corridors, emerged as a planetary circulatory system. Meteorologists, too, grew to appreciate water's central role in shaping weather and storms. Satellite imagery revealed hurricanes spiraling across oceans, drawing energy from warm waters below. Weather models evolved to incorporate the complexities of cloud formation, evaporation, and precipitation, each involving water's constant shifts between liquid, vapor, and ice. Meanwhile, advances in medicine illuminated water's role inside the human body. Researchers traced how water facilitated enzyme reactions, nutrient transport, temperature regulation, and waste removal. Medical science developed increasingly sophisticated methods to restore hydration, manage fluid balances, and purify drinking water for public health. In the late 20th and early 21st centuries, entirely new fields emerged devoted to water's global challenges. Hydrology, climatology, environmental science, and planetary science all converged around water's behavior. Remote sensing satellites tracked rainfall, glacier retreat, groundwater depletion, and sea level rise with precision unimaginable to earlier generations. Water's importance even extended beyond Earth. Robotic probes exploring Mars discovered dried riverbeds and polar ice caps, hinting that liquid water once flowed on the red planet's surface. Moons like Europa and Enceladus revealed subsurface oceans beneath icy shells, raising the tantalizing possibility of life beyond Earth. The search for extraterrestrial life now often begins with a simple question: is there water? Water's story continued to unfold, not as a closed book, but as an ever-deepening mystery. Scientists today still grapple with questions that resist easy answers. Why does supercooled water remain liquid below freezing? How does water interact with complex biological structures at the molecular level? What are the limits of life in extreme aquatic environments? These questions keep laboratories busy and journals filled. The history of water's understanding mirrors humanity's broader intellectual journey, from reverent observation to experimental inquiry, from mystical symbolism to quantum complexity. Each generation peeled back another layer, only to discover new depths waiting beneath. Even now, after centuries of careful study, water refuses to yield all its secrets. Its presence remains both familiar and elusive. The cup on your nightstand contains molecules that have circled the planet countless times, drifting through clouds, rivers, glaciers, and aquifers. Yet within each sip lies a dance of atoms whose subtle interactions remain the focus of cutting-edge research. Water's history is not finished. It continues to evolve with us, inviting new questions, new tools, and new reflections. Through every storm, every melting snowflake, every drop of morning dew, it quietly reminds us that its story, like ours, is still unfolding. Water invites science, but it also invites reflection. Beyond its chemical bonds, its weather cycles, and its biological functions, water whispers ancient questions. Not everything about water belongs to formulas or microscopes. Some of its mystery lives quietly in the spaces where science meets philosophy, in the strange place where thought drifts like a river that refuses to stay in one channel. At first glance, water appears endlessly simple, transparent, tasteless, odorless. It slips easily through hands, seeming almost nothing. Yet beneath this softness lies a paradox. Water is both humble and profound. Entire worlds turn because of it. Life as we know it exists only because water permits it. Many philosophers, ancient and modern, have been drawn to water's dual nature, always changing yet somehow constant. Heraclitus, the ancient Greek thinker who observed that no person steps into the same river twice, pointed towards something fundamental. The river changes with every passing moment. Its waters flow away, replaced by new ones. Yet somehow, the river remains the river. Identity persists through change. The stream teaches that constancy may not require sameness. This image easily stretches beyond rivers. All of life seems to echo this principle. Our bodies replace cells constantly. Our thoughts shift. Our experiences accumulate. Our choices lead us in unpredictable directions. Yet we experience continuity, a sense of being the same person through countless subtle transformations. Water, in its ceaseless movement, models this strange balance between permanence and flux. The Taoist sages of ancient China also saw water's quiet power as a model for life. Laozi wrote that nothing is softer than water, yet nothing surpasses it for wearing away what is hard. Mountains crumble beneath rain, stones are smoothed by waves. Valleys deepen with rivers' gentle persistence. Water conquers without force, it yields yet endures. The Tao invites one to live like water, adaptable, humble, strong without rigidity. At times, the deeper one contemplates water, the more it resembles time itself. Both flow ceaselessly forward. Neither can be grasped or held. Moments pass like droplets slipping through fingers. We live within their flow, unable to pause them, unable to reverse them. Some physicists have even suggested that time and change may emerge from the same fundamental symmetries that govern matter's interaction with space, including the fluid movement of particles that form substances like water. Time moves forward, as does a river. Yet unlike a river, time offers no tributaries to travel backwards. Water may evaporate, rain again, return to its source. But time, in our experience, marches forward in a line. The link between water's cycles and time's arrow has fascinated thinkers for centuries. One renews itself. The other appears to carry us toward endings we cannot escape. Both also carry memory. Water holds traces of what it touches: dissolved minerals, sediments, pollutants, and nutrients. A droplet pulled from ancient ice may contain chemical signatures of volcanic eruptions or atmospheric shifts from thousands of years ago. Time holds memory too, though more delicately, as fragile threads within our minds, susceptible to fading and distortion. We forget. Water remembers differently. These parallels have led some to wonder whether water itself possesses a kind of primitive consciousness. The notion sounds strange within strict science, but in certain philosophies it has appeared for centuries. In some animist traditions, rivers and lakes hold spirit, not metaphors but living essence. Water flows not just through landscapes but through being. Modern science does not ascribe consciousness to water, yet even within its accepted frameworks, water behaves as something more than a passive substance. It responds to forces, organizes itself into structures, and influences life at every level. Its very nature seems poised at the edge of deeper complexity, neither rigid nor chaotic, but delicately ordered. From this perspective, water embodies one of the great questions at the heart of physics and philosophy alike. Is the universe fundamentally deterministic, following strict cause and effect, or is it inherently probabilistic, shaped by chance and uncertainty? Water moves easily between these extremes. At the scale of molecules, randomness abounds. Collisions, vibrations, and bonds form and break through probabilities. Yet on larger scales, rivers reliably carve canyons, rain fills lakes, glaciers grind valleys. Patterns emerge from countless chaotic interactions. In quantum physics, particles exhibit this same strange blend. They exist as clouds of probabilities until measured. They seem neither fully real nor fully imaginary until forced into one state or another. Water's behaviour, though governed by classical rules at larger scales, still contains whispers of these quantum mysteries beneath its surface. Some have speculated that water may even play a role in the very foundations of consciousness. Theories about the nature of mind occasionally invoke water's properties as metaphors for brain activity, fluid dynamics, phase transitions, coherence. While these models remain speculative and controversial, they reflect an enduring intuition that water's strange dance may somehow resemble the inner flows of thought itself. In speculative physics, some researchers wonder whether water's properties might even differ elsewhere in the universe. The balance between hydrogen and oxygen, the specific angles of molecular bonds, the strength of forces holding atoms together, all depend on universal constants. If those constants varied, would water still form? Would life? Or does the universe appear fine-tuned, precisely because water and life require such delicately balanced conditions? These questions touch the edges of cosmology's most profound debates. The anthropic principle suggests that we observe this universe because only universes with such conditions allow observers to exist. Whether this explains water's peculiar suitability remains open for debate. Yet the question itself highlights how deeply water's presence is tied to existence. Speculation reaches even further when considering whether water might exist in unfamiliar forms elsewhere. Liquid ammonia, supercritical fluids, or entirely exotic chemistries may fill oceans on distant exoplanets. Yet water's simple formula remains uniquely suited to its role on Earth. No alternative substance offers the same range of temperatures where liquid can exist, the same dissolving power, or the same flexibility to support life's intricate reactions. Perhaps this explains why our search for life beyond Earth so often begins by searching for water. Instruments aboard space probes scan for ice on Mars, geysers on Enceladus, or subsurface oceans beneath Europa's crust. Where there is liquid water, hope remains that life may follow. Water even enters into the realm of speculative metaphysics. Some traditions propose that reality itself flows, not unlike a river of becoming. Events emerge from the flux, existing only briefly before dissolving into new patterns. The universe may not consist of fixed objects, but of dynamic processes, eddies, ripples, and waves. In this view, water serves not merely as a substance within the universe, but as a metaphor for existence itself. This idea appears again and again across cultures and eras. Buddhist philosophy describes impermanence, all things as transient, flowing, arising, and passing away. Indigenous traditions speak of the great cycles of life, where beings are not isolated entities but part of larger flows. Water becomes not merely something we use or study, but a teacher of how to see the world. Even dreams reflect water's presence. In many cultures, dreams of oceans or rivers symbolize emotional depth, transformation, or spiritual passage. Water, in dreams, carries both comfort and danger. To dream of drowning may reflect overwhelming fears. To dream of floating may suggest surrender and peace. These interpretations mirror water's dual face in waking life, gentle one moment, destructive the next. Stories and myths often center on water's mysterious crossings. Rivers mark boundaries between life and death, between known and unknown. The Styx of Greek mythology separates the living from the dead. Ancient Egyptian texts describe souls navigating watery realms in the afterlife. Even modern tales return to this imagery, invoking rivers as metaphors for transitions, for letting go, for rebirth. The more one contemplates water, the more its nature dissolves into paradox. It yields yet shapes mountains. It moves yet seeks stillness. It holds no form yet defines every form it touches. Scientists measure its properties to astonishing precision, yet its presence stirs feelings beyond measurement. Perhaps this explains why water so often appears in meditative practices. The sound of rain, the sight of rippling ponds, the feel of waves against skin, these sensations quiet thought. Water invites the mind to soften, to drift. In such moments, the boundaries between self and world grow faint. Like fog rolling over a calm lake, the self becomes part of the flow. In this way, water offers not answers but invitations. It asks no questions, yet leads to many. It simply is, moving, cycling, transforming, reminding us that stability need not mean stillness. Life, like water, requires motion. Change is not the enemy of continuity, but its companion. Through this lens, water reflects the nature of existence itself. We are not fixed things, but flowing patterns. Thoughts, memories, and breaths arising moment by moment. We enter life like rivers joining the sea, merge into the great current, and eventually return to the source. Along the way, we shimmer briefly in the light, like waves catching the sun. Water's story does not live only in distant theories or grand cosmic questions. Its presence fills every corner of daily life, quietly weaving through routines, habits, comforts, and anxieties. Though rarely noticed, water accompanies each of us in ways both subtle and essential. Consider how many small rituals begin and end with water. The morning shower that washes away sleep, the splash of cold water on a face before a long day, a kettle gently boiling for tea as dawn filters through windows, a sip of cool water after exercise, the glass placed on a nightstand before sleep. Each gesture feels ordinary, yet behind every droplet lies an ancient journey, The water that pours from a kitchen tap may have fallen as snow on a distant mountain centuries ago. It may have risen as vapour from faraway oceans. Long before it entered homes through careful pipes and treatment systems, it travelled through rivers, clouds, aquifers, and stones. Even within urban landscapes, where nature feels distant, water remains everywhere. Fountains burble in city squares. Rain slicks pavement with shining reflections. Gutter streams carry leaves down neighbourhood streets. People carry bottled water in handbags and cars. Hydration apps buzz reminders to sip, turning something once instinctive into yet another scheduled task. The modern obsession with hydration illustrates both knowledge and anxiety. Health experts encourage steady intake, cautioning against dehydration's effects on focus, energy, and skin. Stylish water bottles now serve not only function, but fashion. Metal flasks adorned with designs, insulated to preserve temperature for hours. Social media trends showcase colourful infusions of lemon, cucumber, or herbs swirling in glass pitchers, promising detox and wellness. This attention to hydration reflects more than just medical advice. It reveals a desire to feel in control of one's body, to engage with water not merely as a necessity but as a ritual of care. In sipping mindfully there is a kind of quiet reassurance, a grounding amid the rush of daily schedules. Beyond the individual, water shapes cultural rhythms across the globe. In Japan, tea ceremonies transform boiling water into an art form. Every movement, from pouring to whisking to sipping, follows patterns passed down through generations. The ceremony slows time, inviting both host and guest into a moment of presence, where the preparation of tea becomes a meditation. In Britain, tea occupies a different cultural space, a daily pause, a social bridge, a comfort in both celebration and grief. The clink of porcelain cups echoes across kitchens and offices alike, offering warmth that is as emotional as it is physical. In desert cultures, water represents something even deeper. A cup offered to a guest speaks not only of politeness but of hospitality's sacred duty. To share water in dry lands is to share life itself. The Bedouin proverb reminds, "A guest is a gift from God, and water is a gift to the guest." Water continues to serve ceremonial roles across spiritual traditions. In Christian baptisms, water symbolizes rebirth and purification. In Hindu pujas, sacred rivers are invoked to cleanse body and spirit. In Islamic ablution, water prepares believers for prayer, washing away distractions of the world. These rituals speak not only to cleanliness but to transition, entering sacred space both physically and mentally. Even in grieving, water plays its part. Tears mark sorrow, streaming from eyes as silent echoes of the rivers that carry emotion through hearts. Mourning often draws metaphors from rain and storm, clouds heavy with grief, skies weeping for the departed. In many cultures, scattering ashes into rivers or seas honours life's return to nature's broader currents. Festivals celebrate water's power as well. Thailand's Songkran transforms streets into playful battlegrounds of water fights, marking the new year with joyful splashing. India's Holi mixes coloured powders with water to create vivid bursts of celebration. Across the world, communities gather to honour water's ability to refresh not only bodies, but spirits. Even humour finds its place in water's everyday influence. Children giggle as sprinklers spray unexpected arcs. Friends tease one another during poolside games. A simple splash becomes a moment of levity, reminding that water can carry joy as easily as solemnity. In language, water saturates metaphors and expressions. People describe feelings as drowning in work or immersed in love. New ideas flow naturally or face a flood of opposition. Conversations dry up or bubble with excitement. Negotiations run smoothly or reach uncharted waters. Water's behaviour, so familiar and versatile, lends itself endlessly to the textures of human speech. Even relationships find comparison to water. Friendships weather storms or drift apart. Partnerships may stagnate or surge forward like rapids. Trust forms gentle currents, while conflict brews under choppy surfaces. Life itself often feels like a journey down a river, sometimes swift, sometimes meandering, always uncertain in where bends may lead. Artists across centuries have turned to water for inspiration. Painters capture its reflections, shimmering with light that dances and refracts. Poets write of rivers as metaphors for longing, for memory, for destiny. Musicians compose pieces mimicking the rhythmic lapping of waves or the pulsing thrum of rain against rooftops. In Claude Monet's paintings, water lilies float upon serene ponds, inviting viewers into tranquil contemplation. In Debussy's La Mer, orchestral waves rise and fall, evoking the sea's ceaseless movement. Haiku poets, with only a few syllables, evoke water's moods. Rain falling on moss, mist clinging to mountains, ponds stirred by frogs' leaps. Storytelling traditions, too, fill with water's presence. Myths speak of floods that reshape worlds, of heroes crossing rivers to reach unknown realms, of fountains granting immortality or wisdom. Fairy tales whisper of wells hiding wishes, of enchanted springs bestowing beauty or curses. Even modern literature echoes these ancient currents, metaphors flowing from subconscious depths into narrative streams. In the natural world, water orchestrates daily patterns as well. Coastal communities rise and sleep by tides. Farmers read rainfall like ancient texts, measuring each season's gifts or challenges. Skiers await snow's arrival. Gardeners turn to rain barrels. Even the simple act of carrying an umbrella reflects a quiet dialogue with water's unpredictability. Children encounter water's lessons early. Puddles invite playful stomps. Bath time becomes an exploration of splashes and bubbles. Summer sprinklers transform lawns into gleeful obstacle courses. These moments of discovery foster early curiosity about nature's textures. The coolness of liquid, the slipperiness of wet skin, the surprise of water balloons bursting mid-air. Pets reveal water's varied place as well. Dogs joyfully leap into lakes, shaking fur into sprays of droplets. Cats approach baths with skepticism. Aquarium fish glide through miniature worlds. Even in domesticated spaces, water remains a source of fascination and occasional mischief. In technology, water hides in plain sight. Power plants cool reactors with water's high heat capacity. Factories clean products in purified streams. Hospitals sterilize instruments with steam. Computer chips are washed in ultra-pure water during manufacturing, where even microscopic impurities could damage circuits. The most advanced tools depend on ancient properties, the same surface tension, phase transitions, and solvent abilities first observed in nature's rivers. Daily conveniences also lean on hidden water. Washing machines hum through cycles of soapy rotations. Dishwashers pulse jets across plates. Toilets whisk waste through pipes toward distant treatment plants. Faucets answer without thought, offering clean streams at the twist of a wrist. Yet behind each instant lies vast infrastructure, reservoirs, filtration, pumping stations, quietly operating out of sight. In moments of leisure, water draws people together. Beaches invite sunbathers and swimmers. Canoes glide across calm lakes. Surfers chase curling waves. Cruises cross open oceans. Hot springs soothe tense muscles. Even simple backyard pools provide escape as bodies float weightlessly, tension dissolving into liquid embrace. Water sports carry both grace and thrill. Divers slice into calm surfaces. Sailboats harness wind to race across waves. Rowers synchronize strokes in steady rhythm. Scuba divers explore coral forests beneath translucent ceilings. Each activity depends on water's predictability and surprise, yielding safety one moment, challenging skill the next. Weather forecasts remind of water's daily role. People glance at apps to check for rain, adjusting umbrellas, coats, or weekend plans. Severe storms shift schedules, close schools, alter flights. Droughts fill news headlines. Floods disrupt cities. Even minor drizzles change traffic flows and moods. At weddings, rain becomes omen or blessing, depending on cultural lens. Farmers celebrate spring showers. Vacationers groan at soggy forecasts. Children press faces to windows, tracing raindrops racing down glass. Sleep itself often welcomes water's presence. Sound machines mimic rain to hush restless minds. Ocean waves loop gently in bedrooms. Meditation apps offer babbling brooks or distant thunder, creating auditory blankets that wrap anxious thoughts. The brain, lulled by these rhythms, relaxes into dreams where rivers may flow again. In aging, water's significance endures. Doctors monitor hydration as bodies grow less efficient. Skincare regimens promise moisture and renewal. Joints depend on synovial fluids. Kidneys regulate balance with delicate care. Even the thirst response grows less reliable, requiring attention that youth once managed effortlessly. Toward life's end, water offers final kindness. Ice chips soothe parched mouths. Hands are bathed gently. Ritual washings prepare bodies for rest. Like birth, like tears, like rain. Water remains present as existence circles back toward stillness. Though people rarely pause to notice, water threads through every stage, every corner, every ordinary hour. Its presence carries both gravity and grace. In its quiet constancy, it reflects not only nature's patterns but life's delicate balance, sustaining, nourishing, cleansing, comforting. No matter how modern life grows, no matter how far technologies reach, no invention has replaced water's essential gift. The streams that flow through ancient forests still flow within veins. The rain that fed ancestors still falls upon today's soil. The droplets clinging to leaves at dawn shimmer with the same quiet magic that first drew wonder from those who gazed upward long before science found words. Water feels timeless, yet imagining its possibilities invites us far beyond daily experience. The same liquid that fills teacups and oceans also leads the imagination into strange futures, alternate realities, and mind-bending paradoxes. Science fiction often begins with a simple question: what if? Water answers that invitation eagerly, offering dozens of threads to pull. Begin with the question of abundance. Water covers more than 70% of Earth's surface. To many, this might sound like excess. Yet most of this water is locked in salt, unsuitable for drinking or farming without energy-intensive processing. Fresh water, what sustains crops, cities, and bodies, makes up only a tiny sliver of Earth's total supply. Nearly all of it hides in glaciers, aquifers, or underground ice. The fragile balance of freshwater availability haunts many futuristic visions. Imagine a world where droughts become common. Climate shifts push rainfall patterns into chaos. Glaciers recede beyond recovery. Rivers shrink to seasonal trickles. Populations fight over shrinking lakes. This is no distant fantasy. Some parts of the world already face these pressures, watching rivers like the Colorado and Yangtze struggle to meet rising demands. Science fiction writers extrapolate this into water wars, conflicts not over oil, but over who controls the last clean reservoirs. Now tilt the vision another way. Suppose breakthroughs make desalination cheap and efficient. Machines transform endless seawater into drinkable supplies, powered by abundant renewable energy. Water becomes limitless. Agriculture blooms even in deserts. Crops rise where once only sand stretched. Humanity spreads into barren regions once thought uninhabitable. Economies shift, population centres grow, and borders are redrawn not by rivers but by pipelines stretching across continents. Yet even here, new paradoxes arise. Abundance breeds complacency. Excess water use encourages waste, polluting remaining ecosystems. Salt byproducts from desalination threaten coastal life. The ocean's balance changes subtly as billions of gallons are withdrawn daily. One problem solved, another born. Some speculative visions extend further toward planetary engineering. Mars, frozen and barren, holds ice beneath its dusty surface. What if humanity one day melts those reserves? Terraforming Mars could flood its dry basins, building rivers and lakes. Rain might fall where no drop has touched for billions of years. A second water world could awaken beneath alien skies. Yet Mars presents challenges beyond mere melting. Without a magnetic field, solar winds strip its atmosphere. Without sufficient pressure, liquid water evaporates or freezes instantly. Terraforming would require not only water, but atmosphere, heat, and long-term stabilization. An enormous task measured not in years, but in centuries or millennia. Farther still, other moons invite speculation. Europa, orbiting Jupiter, hides an ocean beneath its ice shell, warmed by gravitational tides. Probes might one day drill through kilometers of frozen crust, revealing strange ecosystems fed by underwater volcanoes. Life, if it exists, would not resemble Earth's creatures. It might thrive near hydrothermal vents, relying on chemosynthesis rather than sunlight. Entire biospheres could flourish in perpetual darkness, teaching new definitions of habitability. Enceladus, another icy moon of Saturn, offers similar intrigue. Geysers of water burst into space, carrying molecular hints of organic compounds. Missions may soon explore these plumes directly, seeking chemical footprints that whisper of alien biology. Water, once again, marks the boundary between lifeless rock and fertile unknowns. Speculative fiction also ponders stranger properties of water itself. In some alternate universes, water might behave differently. Imagine a world where ice sinks rather than floats. Winter would freeze lakes from the bottom up, killing aquatic life with each passing season. Oceans might lock in ice ages from which recovery becomes impossible. Life as we know it might never arise. Consider a world where water's boiling point changes, where liquid evaporates at lower temperatures. Rain would vanish into vapor, deserts expand, and plant life collapse. Or picture a world where hydrogen bonding is weaker. Surface tension disappears, no droplets form, rain becomes mist, rivers flatten into sluggish films, insects no longer skate across ponds, capillary action ceases, trees cannot pull moisture into their branches, forests wither, ecosystems crumble. The precise behavior of water on Earth depends on countless fine-tuned constants: atomic mass, charge distribution, bond angles, quantum probabilities. A small shift in any parameter might erase liquid water's ability to exist altogether. Such sensitivity tempts philosophers toward the anthropic principle, the unsettling idea that perhaps our universe is merely one among many, and we observe these particular laws only because they allow us to exist and observe at all. Beyond physics, water's speculative reach stretches into the mind. Some futurists suggest technologies capable of manipulating water inside living organisms with unprecedented precision. Nanobots swimming through bloodstreams might repair tissues, target diseases, or even extend life. Water becomes both environment and tool, a medium for microscopic surgeries performed without incisions. In more distant futures, entire cities might float upon oceans. Seasteading visions imagine modular platforms drifting with the tides, self-sustaining societies harvesting food, energy and fresh water directly from the sea. Such floating nations could avoid rising sea levels entirely, adapting to climate shifts rather than resisting them. Yet governance, security and ecology would pose new dilemmas as borders dissolve into waves. The dream of controlling water also carries darker reflections. In dystopian visions, totalitarian regimes ration water supplies, wielding thirst as a weapon of control. Black markets rise to trade illegal access to clean reserves. Communities fracture under scarcity, and water-rich regions guard their supplies with militarized force. Cyberpunk worlds imagine corporate ownership of entire watersheds, where private companies own rain itself through elaborate legal loopholes. Citizens live under subscription models, paying monthly for hydration, monitored by smart meters that track each litre consumed. Even rainfall may be harvested before it reaches the ground, collected by aerial drones feeding high-altitude reservoirs. Time travel stories add further layers of paradox. What happens when future civilizations send warnings backward to prevent water crises? Do altered choices ripple into unexpected consequences? Might preserving one river's flow cause drought in another? The butterfly effects of tampering with hydrologic cycles stretch quickly beyond prediction. Stranger still are ideas where water itself holds time's imprint. Suppose future technologies read molecular memories trapped within ice cores. Could scientists reconstruct not only temperatures but full environmental histories, recording storms, volcanic eruptions, even ancient atmospheric sounds embedded as vibrations within crystals? Each drop might serve as a tiny frozen archive waiting to be unlocked. Some thinkers dream of water-based computing, machines that use the flows of liquid itself to process information. Instead of silicon transistors, networks of droplets could switch, merge, or split in carefully controlled channels. Water's dynamic behavior, combined with advances in microfluidics, might one day create entirely new kinds of organic adaptive computers. Even consciousness itself sometimes enters water's speculative horizon. Could future neuroscience model thoughts as flowing networks akin to liquid dynamics? Some dreamers imagine artificial minds built upon fluid architectures, intelligent water weaving patterns of information far beyond today's circuitry. Water's role in speculative art reflects similar fascinations. Films portray submerged cities, flooded dystopias, or interstellar water worlds. Novels explore ocean planets where civilization clings to floating platforms under alien skies. Video games place players in underwater realms teeming with luminous creatures or ancient ruins reclaimed by rising seas. These visions blend awe and anxiety, reflecting both water's beauty and its unpredictable force. One haunting paradox echoes across these futures. Water gives life, yet threatens it. Coastal cities may thrive beside oceans for centuries, only to face encroaching tides as ice sheets melt. Islands that once blossomed beneath monsoons may vanish beneath storm surges. The same waves that cradle beaches under moonlight may one day erase them altogether. In contemplating these futures, a curious symmetry emerges. Water mirrors humanity's relationship with nature itself, a dance of mastery and humility. We build dams, irrigate deserts, filter waste, and desalinate seas. Yet floods arrive unbidden. Droughts linger. Hurricanes twist with impossible power. Control remains partial, fragile, always contingent. Speculative fiction, in its playful and cautionary visions, reminds that water's story is never fully written. New technologies will reshape its role. Climate shifts will redraw its patterns. Emerging worlds may teach entirely new relationships with liquid life. Perhaps the ultimate speculation belongs not to science, but to wonder itself. In distant corners of the cosmos, countless exoplanets spin in silence. Some may hold oceans beneath their clouds. Somewhere, on some world orbiting a distant star, alien rivers may glisten beneath foreign moons. The same basic molecule, 2 hydrogens, 1 oxygen, may flow through landscapes utterly unlike Earth, feeding creatures we cannot yet imagine. Perhaps one day, explorers will stand beneath unfamiliar skies, dipping hands into strange streams. The water will still be wet, still flow downhill, still ripple in moonlight. Across light years and centuries, water's quiet song may remain the same. Back on Earth, the glass of water on your table contains atoms older than the sun. Each sip connects to that grand cosmic river. Through speculative futures, alternate histories, distant worlds, and impossible machines, water flows on, patient, adaptable, infinite in its possibilities. We have wandered now across many shores, from the ancient rivers where civilizations first stirred, to the icebound moons whispering their secrets in the silence of space, from the delicate structure of a single water molecule to the vast currents shaping continents and climates. Through myths, rituals, science, and speculation, water has been our guide. It remains strange, doesn't it? How something so ordinary, pouring from taps, collecting in puddles, slipping unnoticed down storm drains, holds a story older than memory. A single drop contains echoes of supernovae, whispers of mountain springs, traces of glaciers that ground stone to sand long before human footsteps left any mark. Water carries no ego. It doesn't announce its history. Yet with every glass, every rainfall, every tear, we touch something that has circled the planet countless times. What falls upon your skin tonight may have once been mist in a prehistoric jungle, snow on a woolly mammoth's back, or a ripple in a forgotten sea beneath an ancient sky. It has shaped not only landscapes, but hearts. It holds our reflections. It soothes restless minds with its rhythms. It flows beneath the surface of language, pulsing through metaphors we barely notice, of waves of emotion, floods of change, stillness of calm. Water does not resist. It adapts. It yields. Yet through patience alone, it shapes mountains and carries continents toward the sea. Its lessons arrive softly, like rain tapping on windows. Persistence need not shout to be powerful. In this way, water has always been more than substance. It has been teacher, mirror, and companion. It has reflected humanity's wonder since the first gaze across a quiet lake. It still reflects that wonder now, whether we meet it in a child's laughter beneath a sprinkler, or in the quiet awe of ice cores drilled from the ancient past. Perhaps, in the end, the story of water is also a story of attention, of pausing long enough to notice the beauty carried within the simplest things. A glass lifted to your lips, a raindrop caught on a leaf, the soft sound of waves as sleep approaches. Water asks nothing, yet it offers everything. Its journey continues tonight, as it always has, flowing beneath dreams, circling back again and again. Patient, ancient, gentle. So, where are you now? Perhaps curled beneath blankets, listening to the quiet hum of night. Perhaps the rain taps gently at your window. Perhaps the clock's soft ticking marks each moment as it drifts by like ripples across a pond. Wherever you are, and whenever you are, thank you for floating with me through the long, winding story of water. From ancient ice to bottled springs, from cosmic clouds to quiet cups of tea, water has carried us on a journey both vast and intimate. If this brought you even a moment of calm, a little space to breathe, to wonder, to soften, I am grateful. Feel free to return here whenever you wish, whenever sleep feels distant or curiosity calls. Sleep well, fellow traveller, wherever you are, whenever you are.